Slow computer mode. All right, I had to stop that because it was just going so slow and the screen was not updating. So, all right, back to this. The higher frequency light that comes in. So, the higher the frequency, the more energy the electron will get. This makes sense in all our discussions, but there's a certain point here that the graph stops. The electrons don't get ejected here. So you can almost think of this as two parts. Um, Here we have ejected electrons from the atom. And if you go down below, the electrons are still in the orbitals or within the atom. Now, this y-intercept, this is known as your work function. So we're going to relate the discussion we had yesterday of the work function and atomic energy levels to this graph. So ultimately, if I needed to eject an electron from a hydrogen atom, I would need to have 13.6 electron volts of energy. So I would need a wave, a photon with that high frequency to get 13.6 units of energy to the electron so that is ejected from the hydrogen atom. Basically, drawing this graph, these values here, if we were looking at a hydrogen atom, which we are not, those energy levels can be thought of as what is occurring within the atom. So this graph here below is, you have nothing below that x-intercept because the electrons are still jumping up and down in the energy levels within the atom itself. Once the electron is ejected, this is known as the photoelectric effect. You have enough incoming light energy and to eject it to be greater than the work function, and ultimately that will equal the kinetic energy of the electron that is ejected. So this equation here this is the energy of the incoming light. This here is the work function, which is energy required to eject an electron from an atom or a molecule. And what's left over is the kinetic energy of the ejected electron. So we will discuss how to use this equation. Kinetic energy is equal to the energy of incoming light minus the work function or the energy required to eject that electron. So before we're talking about the energy levels within an atom, this graph occurs within the atom. Once the electron is ejected, the higher the frequency, the higher the kinetic energy.